05955 and here is my presentation on the topic of the theory and applications of bit minwise hashing under the subject of design and analysis of algorithms. In this presentation, I will be discuss an important probabilistic algorithm used in efficiency estimate similarity between a very large data sets. In today's digital era, we deal with massive amounts of data such as documents, web pages, images, and under activity logs, where comparing data directly becomes computational expensive. Traditional exact algorithm not scale well when the data set size increases. Minverse hashing was introduced as a clever randomizer technique to solve this problem efficiency. B-bit minwise hashing further improves this technique by reducing memory requirements while maintaining acceptance accuracy. The topic is important from an algorithmic perspective because it demonstrates how randomness and approximation are used to design scalability algorithms throughout this presentation. I'll explain the theory behind minwise hashing, the motivation for B-bit optimization, and its real-world applications. So, problem definition. The motivation behind minwise hashing arises from the need to efficiently compute similarity between large sets in many applications such as document comparison, uh, plagiarism detection, and web indexing. We need to determine how similarities to data sets are commonly used. Similarity measures is Jaccard similarity, which compares the intersection and union of two sets. However, computing this similarity exactly requires scanning all elements, which is computationally expensive for large set data sets. For example, comparing millions of documentation pairwise using traditional methods would require enormous time and memory. So, scanning all elements, which is computationally expensive for large data sets. For example, comparing millions of documents, this makes exact algorithms impractical. Therefore, algorithm designers took look for approximate solutions that provide good accuracy with a lower computational cost. Meanwhile, hashing was developed to address this issue. It provides a probabilistic way to estimate similarity efficiency, making it highly suitable for larger scale systems. Jagged similarity. Jagged similarity is a fundamental concept used to measure similarity between two sets. It is defined as the size of the intersection of two sets divided by the zero of their union. For example, if two documents share many common words, their Jaccard similarity will be high. This metric is and widely used in information retrieval and data mining. However, computing Jaccard similarity directly requires comparing all elements in both sets. As the size of the sets increases, the time complexity becomes very high from an algorithm analysis perspective. This approach does not scale effectively. This limitation motivates the need for approximate algorithm and that estimates the similarity without full comparison. Meanwhile, hashing provides a way to estimate Jaccard similarity using compact representations, making it suitable for large data sets. Minwise hashing concept. Minwise hashing is a randomized algorithm designed to estimate Jaccard similarity between sets. The core idea is to apply a random permutation to universe of elements and then record the minimum hash value for each set. If two sets are similar, they are high probably and their minimum hash values will be equal. In fact, the probability that the minimum hash values match is exactly equal to Jaccard similarity of the sets. By repeating this process multiple times using different hash functions, we can obtain a reliable estimate of similarity. This approach avoids a direct set comparison and significantly reduces computation. Meanwhile, hashing a classic example of how randomness come from user to design efficient algorithms. It demonstrates the power of a probabilistic technique in solving large-scale problems. Need for multiple hash functions. To improve the accuracy, meanwhile hashing, multiple hash functions are used. Each hash function produces one mini hash value, and together they perform a signature for set. The similarity between two sets is estimated by comparing their signatures. The more hash functions used, the more accurate must be stored. In the large scale applications, such as search engines, storing many hash values for millions of documents becomes expensive. This creates a trade off between accuracy and space from an algorithm design's perfect perspective. Limitations of standard minwise hashing. Although standard minwise hashing is efficient compared to exact similarity computation, it still has limitations. Each hash value typically requires 32 or 64 bit of storage. When thousands of hash functions are used, the memory requirement becomes significant in large systems. Uh, Dealing with millions of data sets, the storage costs become a major concern. Additionally, storing process large hash signatures can slow down the system. These limitations make standard minwise hashing less suitable for many consideration environments. Algorithm designers therefore look for ways to reduce memory usage without scaring too much accuracy. This led to development of B-bit minwise hashing, which is a space-optimized version of the original algorithm. What is B-bit minwise hashing? B-bit minwise hashing is an optimization of a standard minwise hashing that focuses on reducing memory usage. Instead of storing the entire hash value, only the lowest B-bit of each hash are stored. For example, instead of storing a 32-bit hash, we may store only 1, 2, or 4-bit. This drastically reduces the storage requirement. So, theoretical analysis of B-bit minwise hashing. The theory behind B-bit minwise hashing is based on probability and statistical estimation. The probability that two sets have the same b-bit hash value depends on their Jaccard similarity and the chosen value of b. As b increases, the probability estimate becomes more accurate, but memory usage also increases. As b decreases, memory usage is minimized, but variance in the estimate increases. This trade-off must be carefully analyzed when designing algorithms. From a theoretical perspective, B-bitwise minwise hashing provides unbiased similarity estimates with controllable variance. This makes it suitable for large-scale approximate computations. The theoretical guarantees of this algorithm make it replaceable despite its probabilistic nature. Time and space complexity. One of the biggest advantages of B-bit minwise hashing is sorry, time and space complexity. The time complexity for computational hashing signatures is linear in the size of the input set, which is efficiently for large data sets. The space complexity is significantly reduced because only B bits are stored per hash value. This makes the algorithm highly scalable compared to exact similarity computational, which is expensive in both time and space. B-bit minwise hashing offers a lightweight alternative from the perspective of algorithm analysis. This technique transforms a complex problem into manageable approximation problem. This efficiency is the main reason why B-bit minwise hashing is widely adopted in practice. And applications in document similarity. One of the most common applications in B-bit minwise hashing is document similarity detection. Search engines use this technique to identify duplicate or near duplicate web pages. Plagiarism detection systems compare large number of documents efficiently using hash signatures. Instead of comparing full documents word by word, compact hash representations are compared. This drastically reduces the computation time and memory usage. For example, millions of documentations can be processed quickly by using Bibit Minwise hashing. This application clearly shows how algorithmic optimization improves system performance. It also demonstrates the real world impact of theoretical algorithm designs. Applications in and data handling and machine learning. Bitwise hashing and also widely used in data mining and machine learning applications. It helps in clustering similar data points and finding approximate nearest neighbors. In recommendation systems, it is used to identify users with similar preferences based on activity data. Larger sets are converted into small compact signatures, making similarity search faster and more efficient. This pre-processing step reduces the complexity of learning algorithms. Conclusion and key takeaways. In conclusion, B-bit minwise hashing is a powerful algorithmic technique that efficiently estimates similarity between large data set. It builds upon the theory of approaching balances accuracy, memory usage, and computational efficiency. The wide range of applications in search engines, data mining, and machine learning shows its real-world relevance. Overall, B-bit minwise hashing is an excellent example of how theoretical algorithm design translates into practical scalable solutions. Thank you, sir.